Okay, so I just made announcement in the case you asked
Yes,
for the
thank you for that.
Yeah, so basically I record it and I upload it into YouTube, and you can see in my I have the list. Yeah, I have the playlist for this one. And this one is for the adapt on 40 years. So basically if you miss anything on the class, you can come back to watch it in the list here. Okay, so if you do not have any question, let me go with chapter 6 here. So basically, I mentioned in the class that I want to speed it up a little bit so you have more time to work with the final project. Okay, so for this week, we go with chapter 6. Chapter 6, everything about the how we design with the function. So basically, so far, sometimes you did with the function. You also have some of the built-in function in the Python. Think about you have the print function, you have the range function, they have the built-in function, right? And also you can design by the own. You can bring your own function, and that is something you mentioned in this chapter here. So a quick review about what functions are and how they work. So the function package is an algorithm that is a chunk of code that you can call by name. The algorithm, what is it? Algorithm it is a sequence of the code and it giving out specific outcome, right? You also know about that one. A function can be called from anywhere in program code, including code within other function. A function can receive the data from the each call via the argument, and when the function is called, any expression supplied as argument as the first evaluate. And the function may have one or more return statement. So you think about this one here. That is very simple program, right? So basically, when you work with program, remember that the for any program that so whenever you have the main function, that is where the program is starting, right? So basically, when you compile program, when you run the program, it goes to the main function, right? And you look in the body of the main function. What is it? For if you look at this example here, what is it? You got the length from the user, right? And you got the width from the user, and you see you call out the built-in function print, and in the print function again, you call for the function rectangle here. So remember that anytime if you have if the function is a call, anytime if the function is a call here, so think about this one. When the call about the rectangle function, the program will jump into the function, and execute everything inside the function. And after that, you come back to the main function here. Right? So now think about this. Think about this function here. What you have in this function here. So basically for this one here, right? So when you define the function, you use the def here. That when you want to define the function. Right? The rectangle here is the name of the function, and the x and the y they are parameter. Right? And in your program, whenever you call the function, whenever it's a call function, the action is that in passing the value with into the parameter here, and it's passing value into the parameter. So they are called in the argument here. And so you have to make the parameter clear of the difference between the parameter and the argument. Parameter is that it is a variable you use when you define the function, when you declare the function. Right? And the argument is the value you passing it into the parameter when you call the function. Right? So basically, for this, this is very simple program, right? You got the length and width from the user. If you want to figure out what's the area of the rectangle, right? So that you see, the first step you define the function rectangle. You got the two parameter here. X, that means you have the length, and Y, you have the width here. Right? So when you got the length and width from the user, and you call the function, and you figure out what's the error. What's the error here? And you have the return. This one, the function, you have to return the value of area. And that's what, when you print it out, what's the area of the rectangle here. Okay, so for this one, for this very simple example, you have one return. You have one return. That is area. But remember that a function they can have more. They can have one or more return statement, not only one. That is not only one here. Now think about when you run this program, right? So think about when you run this program here. It's a very simple program. Okay, so see when you run it, I got the length and the width from the end user. So think about have the length 20 and the width 10, and figure out the area here. So if you look on this program, I only have the one return statement only, right? But what in the case that think about in the case I want to figure out about what is the name? A circumstance, right?
Oh, circumference.
Circumference, yeah, right. So you can define one more variable, right? Right. So in that case, you will say to the 2 times x plus y, right? Right. That is a circumference. And in that case here, you can return it. Right? So it's not only return one area, but you can return about the circumference. Right. So what happened here? When you run it, again, I have the length is 20. I have the width is 10. It printed out. Is printed out what is the area, what is the circumference, right? So here's my question: if I want to print it out separately, what is the area and what is the circumference? How can you do it? What is it?
Since it's a tuple, can you use the square bracket?
Sorry, say it.
Since the output looks like a tuple.
Yes.
Can we use like the square bracket like 0 and then 1 for different positions?
Yeah. So basically, you see, when it return here, it's returned in the list, right? In the list here. So basically, if you want to access it separately in each element of the list, you can use the index number, right? So basically, you think about this one here. You can think about I have the. Think about I have the list here, right? I can have my list. I decide to the rectangle, right? So yeah, so I can print it out. The area is, and you can accept it to the list, right? You can accept it to the list. Yes, you can have my list. Why this one?
It's because my list has an extra one.
So for this one, we have 0 here, right? That's the first element. So we have. So basically, that if you have more than one element to return, it already return in the list format. Right? And if you want to accept it separately on each element, you have to use the list and you use the index number. You have a 20 here, have a 10 here. So it works, right? So basically, that is a very simple definition of the function. You have some of the function, and function has the abstraction mechanism here. An abstraction is that means it's a high detail, and you know that when you work with the object-oriented program, right, you have something about abstraction here. Right? In the abstraction is that it is a higher detail that allows the person to view many things. That's one thing. And we use abstraction to refer to the most common task in the everyday life. All right. For example, expression doing the laundry is that now that is something you want to do the laundry, but actually in the stack of the laundry, you have a lot of stacking. Right? But from the user point of view, you do not have to care about that. You do not need to look into the details of this one. Okay, and the effective designer must invent useful abstraction to control the complexity. You break it down into smaller one, right? And if we use the call the function here. Okay, so that is you can think about that another example when we work with a function for this one. So for this function, you define the function and you have the lower range and you have the upper range. And the purpose of this program is the purpose of this program that you have to find it out. You have to find out the sum of all the number in the range from the lower range to the upper range. Right? And when we define the function, and this is a function, is the name of the summation here. That's the name of the function with a summation, and you have the two parameter here. You have the two parameter here, right? So see, when you define the function, every time if you want to call the function, you use the name of the function, right? And you pass in the value for this one. Right? So basically, if you think about from the user point of view, I know for sure that if I want to figure out how to sum of all the number from the range from the lower to the upper, I use the syntax of the function name, and I passing the lower end and the higher end here. That's all I care, right? And I do not have to care about what's inside of this one here. So that is the abstraction. It hide out everything complexity in the function body here. Make sense? Okay, so see, anytime if I want to figure out what the sum of all the number in the range from the lower end to the higher end, I just need to know for sure I have to use the function name and the lower end and the higher end. Okay, and also function say that the abstraction mechanism by eliminating redundant or repetitive code reuse. Think about this one, right? You think about this one very straightforward here. You just need to define the function one time only, right? But after that, you can call it many times as you want. So it is eliminating the redundant, or it can use the repetitive code here. Okay, so I think it's that all by the definition. Okay, now so why you have to work with function? You know that the function you have some benefit, right? The first thing is you work with the abstraction here. It hides the complexity. The second thing is that in the well-organized system, each part has its own job in the collaborating to achieving the common goal, right? So in the computer program function can enforce the division of labor. That means you can break it down from the complex program. You can break it down into submodule, and you can assign each of the submodule to specific team. Right? So you think by very complex program, you can work as an enforce of the division of the labor here. And each task required by system can be assigned to a function, and each function you can assign to the specific team. Okay, and you have the two types of function. The first thing is the void function. The void function is simply executes a statement it contains and then terminate. It not return anything. Is that whenever you call the void function, it will execute everything in the body of the function, and it just terminate. It not return anything. And the second type of function is the return function. It executes a statement it contains and then return a value back to the statement. So when you return the value, you can use it later, whatever you want, right? So basically, it's this one here. This is a void function. That is very simple example of the void function. You just define the function, and you just do everything inside the body of the function, and you just terminate it. Just terminate it. You do not return anything. But for this one here, okay, come back to this one here. Again, come back to this example. If you want to print it out, what is the area of the rectangle, you have to use the return here. And when you have the return value, you can use it later on the program here. Okay, so you can see on the example here, you have the two examples of the two types of function. The first one is the void function. You see in the void function here, it has nothing to return. It has nothing to return in the void function. So you have the program, right? When you call the message, what's the message? Message is that's the definition here. That's the function. Is that print the two line away? That's all. That's the program for the point function here. Alright, but when you work with the return value, right? So remember that when we work the return value, you have to use the return here to return what value you want to store, right? So basically, you see, if you come back to our example before, and close it here, right? The example before, for this one, for this program, if you want to return both of the area and the circumference, you have to use this return, and you have to put it the two element you want to return the case. Right? Okay, now about the definition of the function, you have the consist of the header and the body. So basically, that's the syntax when you define the function, right? When you use the depth here, that's when we can define the function. And square here, it is the name of the function, and x here is the parameter of the function, right? So a function can be defined in the Python shell, but normally it is more convenient if you work with the idle window, or in that case, I work with the visual still here, right? So the syntax of function, remember the syntax of function, you have the depth, you have the keyword here, you have the keyword here. That means definition, right? That is a function name, and you have the parameter here. So it depends on the program. In the function, you might have no parameter, or you can have one or two or more than that definition. Parameter here. So when a function is called, the interpreter will jump to the function and execute statement in the block, and the interpreter jump back to the part of program that calls the function that is known it's a function return here. So think about this one. Again, every program starting from the main module, right? That is when you call the main function. What is it? What is the main function here? Main function, you got the length and you got the weight from the user, right? Now it's a call in the built-in function print, and it's a print function. It calls to the another function here, right? And go. So remember that every time the interpreter jump into the function and execute statement in the block. So whenever you call the function, right, the program here, the interpreter will jump into the function, execute everything in the body of the function, and in that one you have the return here. That's why it returns the value of area, and it takes back. So when you're done with the function here, again, it's jumping back to the main function, right? And we print it out. What's the area of the rectangle here? Okay, that again, it is about you have to make it very clear the difference between the parameter and the argument here. Parameter is the name of variable you use when you declare the function, when you define the function here. Now think about this one here. If you look at this example, x and y, they are variable and they are parameter. You use this when you define the function. But the length and the width, they are argument. Right? And you got it from end user. And when you call the function, the value of the length and the width in passing it from the argument into the parameter. Make sense? Okay. Okay. Also, you can have they also have the no. You also have the function with the no parameter for this one also. You just define the hello, but you have no parameter for this one, and you just print it out hello world. Okay, now the problem is solving with the top and down design. Top-down design start with the global view. You can think you have a complex program of the entire problem, and you want to break it down into the smaller one. It's more manageable sub-problem. Right? It's known as the problem decomposition here. Decomposition. That means you break it down from the complex one into the multiple smaller one. And each of the sub-problem is isolated, and each solution is assigned to the function, and the function is developed to solve problem. The solution to our problem is the guy we figured out here. So that is the most common one. Yeah, when you want to design program to use the function, that you can work with a flow chart here. So in the case of a flow chart, the function core is shown as a rectangle. Right? So when you see, so in the flow chart here, in the flow chart, when you see the rectangle and you have the rectangle with the vertical bar at each side, that is a function. So that is function. So basically, when you look in the flow chart for this one here, everything works in the sequence at the beginning. So see, display here, I have the message for you, and this is a function. So remember that whenever you have a function, the program, the interpreter, will jump into the function, and again execute everything inside the function for you, and it return. So when it return here, when it return to the sorry. So when it returns the main module, right? When it returns the main module, it moves to the main module and it moves to the next statement of the main module. Okay? So again, that is the way program works. Again, it runs it from the main module. Starting in the sequence order. So starting for this one, display, I have the message for you. You have the function. When you call the function, it's jump into the function, execute everything inside the body of the function. And what return? It returns to the back module and you move to the next statement of the main module. Okay, and the function name is written in the symbol and typically draw separate flowchart for each function in the program. And terminal symbol that usually is the return here. That means you have to return it to the main module. Okay. Also, in order to break it down into some smaller one here, you can use the hierarchy chart. Hierarchy chart very straightforward. You can understand the connection, the relation between the function here. So if you look in the hierarchy chart for this one here, the program have the main function, right? And means that you break it down into the multiple function here. And again, for each of the function, you can break it down furthermore. That is a process of top down here. You break it down from the complex one and break it down furthermore. Okay. Now that is the case you design with the top and down design, right? Another approach you can use that is it is designed with the recursive function here. So in the top-down design, you decompose a complex program in the set of simpler program, simpler program, and so on with a different function. In some case, you can decompose complex program into smaller one of the same form. That is very important here. You have a very important concept here. You break it down, you decompose the complex program in the smaller program of the same form. Right? That is very important concept when you work with the recursive here. Subprogram can solve using the same function, and this design strategy called the recursive design, and designing the function are called the recursive function here. So it's all about the definition, but it should be better we work with the specific example here. Now, in the case if you want to figure out what is the fractional of the integer number, so normally you can think about a function. You can think about the function, and you have the one parameter here. That's the number. I think about if you want to figure out what is the fractional of the integer number n here. So basically, it's the n fractional. It's everything from the 1 times 2 times 3 come all over to the n here. Right. So see, this one is very straightforward when work with the function. Right? Is that if and it's starting from the number 1, and you run the loop, the second iteration times the 2, the third iteration is times the 3, and the fourth iteration times the 4, and so on here. Right? That is very simple when you work with the iterative function here. Right. So I think that is very simple program. This one. Here. Yeah, that is program, right? That is program if you want to find it out in the iterative way here. In the iterative way, how to find out the fractional here. So we just define the fraction, the function here. And in that one, you only have one parameter. That is the number. That's the number here. And if starting from the fractional from the number one, now you run the loop. It runs the loop for the I in the range from the 1 to the n plus 1, because in the range is starting from start number, but not includes the n number. That's why I have to add it to number 1 here. And every time the new fractional, it is an old fractional time with the y with the I here. So it's I just return what the fractional here. And in the main program, I got the input from from the user. What is a positive integer number? And again, I print it out. In the print it out, I call the function here. That's the step I call the function here. Is that the step I call the function? And I passing the argument of the number to the parameter n here. And I return what is my fraction here. It's very simple program with this one. Okay, so that is normally the way you work with, right? That you have the iterative here. You have the fractional number 1 here. You always have starting point, right? Otherwise, it has no way to find that here. You always have starting point for that one. You have the loop in the range from the 1 to n plus 1 to find out the new one is the 1 time 1 here. So I think by put the number 5. You see, I get 120 here, or you can change it down by the debugging exercise. You can see how it works. So we think by number 5. You see the first step here. The I is number 1. The fractional here starting from number 1. Now for the second iteration, here, I number 2. That's why fractional new one is the 1 is that 1 times 2 here. That's why it changed it to 2. Yeah. And now 2 times 3, you have the 6 here. Now you have 6 times 4, you have 24 here. And now the last one, 24 times 5, you have 120 here. Okay. It's very straightforward when you chase it down in iterative way. Okay, that is the iterative way to work with the function here. But if you look in the program when you work with the recursive function here, remember that recursive function you work with the function on the same form here, right? The recursive function is the function that call it to itself, recursive, right? That's call it to itself here. To call it to itself, right? So to prevent the function from repeating itself indefinitely here, you must contain at least one selection statement here. It's very important concept. So when you work with the recursive here, you must contain at least one selection statement. Otherwise, program will go run it forever. It's an endless loop here. And the statement examines the base case here. The base case to determine whether stop or to continue with another recursive step. So if you change down here, it's to change down in the recursive here. My base case is that whenever you have the number 1, my fractional is the number 1 here. And if you have to think about this one here, if I want to find out what is the fractional of the number 2, I know that it's a 2 times fractional of 1 here. And if I want to find out what the fraction of number 3, I know that it is a 3 times fraction of 2 here. And again, what is the fraction of the 4? 4, it is a 4 times fraction of 3 here. So see, it calls it to itself, right? Fractional, call it the fractional, fractional, call it the fractional, and fractional here, call it to the fractional. The only difference here it is argument. And this one is argument number 4, but this one argument number 3, this one argument number 3, and this one argument number 2, and this one argument number 2, and this one argument number 1 here. You see, that is recursive. It calls it to itself. It's called it to itself here. So how it works with the Python here? How it works with the Python is this program here. You see, again, I define identify the function name, and that is one parameter only. Again, remember here. Remember here, it must contain at least one selection statement. And in the selection statement, it is a base case to determine whether to stop or to continue another recursive step here. So see, you have at least contain at least one selection statement. It's my selection here. If that is selection, and now if n is one, the fractional number one here. If not, what we think here? If not, you have a fractional. It is coded to the itself here. The only difference here is it is a argument here. It's an argument here, right? So this one less than for this one, and you have the number time to the function here, and you can change it out here. Now, what happened here? If you want to find out the 5 fractional, you can find it out from the 4 fractional time it to the number here. And if you want to find out what is the 4 fractional, you can find the 4 fractional from the 3 fractional time to the number 4 here. So see, this step here is a translation from this one here. Make sense? Yeah, it's very straightforward for this one here, right? It's very straightforward for this one. And remember that the recursive is step you call it to itself. The only difference here it is a parameter number or argument number here. Okay, so for this one again, you can run it, you can change down here. So how it works with this program? How it works this program here, you can change down by the process of the chasing down here. So it works here. Now come back again. Right? So in the program, in the main program here, you call the function here. You call the function. You get recursive fractional number. So think about if I enter the number 5 here. If I enter number 5, it calls the function get recursive fractional number 5 here. Now, so how it works with this program? So how it works with this program here, right? You get fractional number 5. So how we find out? You can find out fractional number 5 from the 5 times to the fractional number 4. Right? And from the number 4 again, you can get the fractional number 4 from the 4 times to get fractional number 3. And how can you find 3? Again, you can get it from the number 2. And how can you find 2? You can get it from the number 1. And number 1 here, it is the base. You stop it. Otherwise, if you do not define the base, it goes to the negative 0, it goes to negative 1, it goes to negative 2, and so on. It goes forever. Okay. So again, in order to understand about the process of recursive, it should be better you run it in the debug mode here. You run it in the debugging mode here, very straightforward. For this one. Recursive here, so getting about this one, change that. Now run it. Okay, so now I've entered the number 5. Okay, so now we go to number 2. Okay, so see, now we have the fractional number 2. You got the return again the recursive function of number 1. What happened if you have the number 3 here? You have fractional number 6 because it return from number 3, and so on here. So on, and the last one here. So that's the process you work the recursive. So remember that in the recursive, you have to work here. It must contain at least one selection statement here. So what happened here in my program? What happened here in my program if I do not have the process here? So what is it? You can see what happened here if I do not the process for this one. You got the analysis loop here, right? See in analysis here because you have no stop. You have no stop point. You can run it again.
could be, it just overflowed in.
Yeah,
values and then
yeah, it
just
should be. Yeah, I think.
Oh, there's an error. Oh, no, never mind. That's just saving.
Yeah, no. What happened?
Oh, this is the wrong program.
Okay.
It's the next tab.
This one.
Yep.
What is it?
Return none.
Yeah. Because it maximum because it's there.
Yep.
So basically that's the way it changes that, right? So if you go back to this one, if you go back to this program here, right? So in that case, when you do not have divisor base here, that means stopping point, right? You do not have the return one here. That keep going on, right? So that's one. You get it from the fractional number 0. Get it from the fractional number 0. Where? Very annoying with this one. Right? So see, if you do not define the base here, right, it goes forever. It gets 0 here. And from 0, again, it gets -1. And from -1, it gets -2, and so on. It goes forever. Right? So that's why it's very, very important that in the case you define for the recursive function here, you have to keep in mind that in the case you define the recursive function, you have to remember that it must contain at least one selection statement. And what is a selection statement? Selection statement is a base case. It tells the program where you stop chasing that, right?
It's like just defining this is your out, this is a stop state.
Yeah, this is a stop. That's a stop. Otherwise, run it forever. Okay, so yeah, here you have another example that is that example is as a Fibonacci sequence here. That is the definition of this sequence. That's the definition of the sequence here. So when you have number 0, the function is 0 when the number 0, and you have the number 1. You also have the function is number 1, and otherwise, see, you write it down here. The n from the n plus n minus 1 and n minus 1 to here. So see, they have the same name. They have the same form, right? But the only difference here it is an argument here when you pass it to them. Okay, that is an infinite recursion analyzed one program here to specify the case. That is my example here. Right? So when you are not define the base case, what is it? Base case that you have to use the selection. You have to find if in this example if the number is 1, you set the fractional number 1, otherwise you will forever here. Now you can see about the recursive and the iterative also. Both of the way work, right? And somehow we can find that the recursive very interesting, but of course it comes with a code. It comes with a code here. Now think about this one. For each code of the function, computer must allocate the call stack to the stack frame. Think about this one here. Think about if you want to find it out. If you want to find out the fractional of 1 million. Right? So how program work here? How program work with in the case with the recursive here? In the case of the recursive, in order to find out what is the fractional of the 1 million here, you have to find out what is fractional of the what is it? 999 something here, right? And again, you have to store it. You have stored into the buffer. In the buffer, we have stored the value of this one here, right? In order to find out the 1999 here, again, you have to find out for this one. So we see down the end, you have to reserve many slots of the memory in order to store the process here. It's really consuming a lot of the memory, and it might run out of memories in program, have millions of the open function code. Because see, when you call to this one, it not immediately find out the value. Again, you have to point it to this one. Again, this one have to point it at the one, and so on. All of them, they are open stack. All of them, they are open stack here. So see, if you have million of the recursive code, it may run out the memory. See, program have millions of the open function code here. That is something you have to pay attention when you work the recursive here. The code, is not scale up like the iteration, require more memory. And in many language iteration, solution way better when you compare with the recursive here. And sometimes it's more abstract or harder to understand than the iterative solution. Again, it's recursive. I think it's a little bit harder to understand. Right? Not really straightforward. And pro, in some case, it's extremely fast and easy to come. It's cheaply practical to for the tree traversal and binary search for in the case of some of the application here. So basically, that's everything about the definition of the function. Everything about the definition of the function. Remember that in the function, when you define it, you have the function name and you have parameter. And whenever you call it, you passing the argument into the parameter. And you learn about something about the top-down design. You break it down in smaller one and work with the hierarchy chart here. And also we work with the recursive function also. Now we go with some definition of the variable here. Now the first thing is about local variable. Local variable is a variable that is assigned a value inside a function, and it belongs to the function which is created. And only statement inside the function can access it. Error will occur if another function try to access to the variable. So think about this one here. So think about this program. I have the main function for this one here. I have the main function for this one. Again, it's a main function. It's a main function here. What is it? I call another function. It's a get name here. And in the get name, what's the function? What's the get name? I get the name, right? And I get the name. Think about this one here. I enter a for the name here, right? So we see when we're done with this program, jump it back to the main program and move to the next statement here. Right? Now print now hello name. This one is a caught error here. The thing is that it's caught error here because the name here it is a local variable, and the scope of local variable is only contained inside the function only. Right? So basically, it only contained in this function here. So when you go back to the main module, you call the variable name here. It's a caught error here because it not understand what is the name variable here, because the name here is only contained inside the function, this function.
So instead of name, it should be get name.
This one, yes, you have to call the function. Okay, the whole function here. It cannot call the specific variable of the function. Okay, yes, that is good approach here. Now think about this one here, right? All right. So think about this one here, right? So instead of using the name here, you have to use the get name if you want to print it out. Yes, you have the exception here, right? Name is not defined because it's not defined in this function here. But of course, you are right. You can use this one here, right? You can use what? Can you what here? What is it? And here, I can see hello. Get name here, right? What is it?
If we're going to do that, we need to return the name and get
Yeah,
the
right.
function.
You have to return it there, right? Yeah.
To give that a return function.
Yeah, because when you call the function, you need to return it something.
Otherwise, it just doesn't return it. You give it a name and it doesn't do
Now
it.
see how it works. Yeah, you have the problem here.
It has
Okay,
that
also-
none type error.
Because get name doesn't have anything to return, so it just dies.
It was like last week when I kept doing my list equals my list dot sort.
Yeah, because sort was a void function.
Yeah, right. Okay,
There we go.
yeah, alright. So when you call it, you need to return something here. Okay, so that is local variable. Okay, and a different function, but they may have the local variable the same name. It doesn't matter, right? Because the name is only contained inside the function array. So even that they have the same name, it doesn't matter. So think about this one here. You have the function name number one. They have the local variable name, right? And you have the another function name number two. Again, they have the local variable. It's a name here. Even that they have the same name, it doesn't matter. It doesn't matter this one. Now, we learned about the local variable, and remember that local variable only contains the scope of the function it created with, right? But sometimes you want to access it from the outside of the from the another function here. In that case, you have to work with the global variable. So global variable is created when a size statement written outside all of the function. Alright, so when we declare the function outside of the function, you can access it from any function of your program. Alright, so when you define create it outside statement outside the auto function, it can be accessed by any statement in the program from any function. I think about this one here. I have my value is number 10. That is global variable because I not contain it inside any other function here, and of course I can call it from my function show value here, right? Because this one is a global variable. Okay. Now, if a function need to assign value to the global variable must be redeclared within the function. Right? So what happened here? What happened if I want to change the value of the global variable? If I want to change the value of the global variable, it's my value here in my function, this one. In that one, I have to redeclare with the function, right? And general format here, you have to use the global and you have to put the variable here. Now, think about this one here. That is the way you want to change it here. The way you want to change it here. The global, you see, you have to redeclare with the function and general format here. You have general format, you have to use the global, and you define the name of the function. Right? So for this one, you can use here, print the value here. Now you can change the value of the global variable. You can change it here and you print it out here. Okay, so the argument again, that's the definition of argument and a parameter, and you know that already, right? A parameter is that is a variable when you define the function. Right? So in that case here, in this example number here, it is a parameter. Right? But when you have the show double and have value here, that means you passing the value number 5 into the parameter number here, and you call the function is passing the number into the parameter. Okay, and so in some case you want to passing the multiple arguments. So not only for this one you only have one argument, but in some of the function you might have the more than one argument. You might have more than one parameter here. For this example, for the function rectangle here, you have the 2 parameters, right? So the Python allow writing a function that accept the multiple argument. Right? So the parameter list replace the single parameter, and parameter list items separate by the comma here. And the argument are passing by position to corresponding parameter. Right? So we see the first parameter receives the value of the first argument, and the second parameter receives the value the second argument for this one. So again, for this one here, right? It's by this one is not actually, this one is not really important about the position. The length and the width, even that when you revert it, it's the same. Right? The length and the width revert it is the same. But again, this one passing the length is a 20. When you call the function here, this one passing the value is a 20 for this one, and the 10 is for the one here. But in the case you think about, if you want to find out the difference between the two numbers, the position is very important. I have to think about if you want to find the difference of x and y here. And if you have x is the number 20 and y you have number 10. So the difference is x minus y. You have number 10 here. So see, that is very important about the position. Right? When you passing the argument to the parameter here. So what happens if you put x number 10 and the y number 20? Now the difference is negative 10. Right? That's why the position when you passing the argument, the position when you passing the argument to the parameter is very important. Okay, and you can make a change to parameter within the function, not affect the argument. Think about this one here. You have the main function here, right? And again, in the main function, you have the value 99, and print out the value here is 99. And now you call the function change me. You call the function change me. You call the function change me. In the call function change me here, you print it out. I'm changing value. I set the argument to 0. Now I print it out in number 0 here for this one here. Now I bring it back to the main value. I have value here. What do you think? What is the output of this program? If you change it down program, what is the output here? What are the output? What are the output of this program? Now change step by step. What do you think?
0?
Values should still be 99 since
No.
it's a local variable.
Now the first one here, what is it? For this one, what do you think? What value here I have?
99.
99. Okay, 99. Now change me value, go back to this one. What is this? What is the second print now here?
0.
0, right? And now back in the main value, what is it?
99.
Yes, stay the same here, 99, right? So see, the change made to my parameter within the function is not affect to the argument. You know, and it have no effect.
Doesn't make sense.
Yes.
Value is a local variable, so it can't be changed.
Yeah.
The other thing is, change me doesn't even have a return values or a return statement, so it can't even put out that, can't even force the value to change. So.
Why is only one? Output.
Run again. There we go.
If value is 99 and then changes to the return to value, or what is it? The change value from 0, but then it goes back to 99 with the local variable.
Okay, so you have many ways to passing the value from the argument to the parameter here. Now we can use the keyword argument. Keyword argument is the argument that specify which parameter the value should be passed through here. And when you work with the keyword argument, the position when calling is not irrelevant. You can mix it up. But remember here, in the case you have to make it up, you only have to specify the position first before it's the other one here. Now think about this one here, right? You see, you have to define the function here, the show integer, and you have the two parameter. You have the principal, you have the rate, and you have variable here. But when you passing the value with the key argument here, the position it doesn't matter, right? You can mix it up here. You have the rate first, you have period second, and you have principal third. It doesn't matter because you already specify the value of that one, and it is a keyword argument here. That's why the position when you call the function is variable. It doesn't matter. Now, also you can possible to mix the keyword and the positional argument when you call the function. But remember one thing here. In that case, positional argument must be appear first. It must be appear first for this one, right? So for this one here, you see, for this one, in passing the 100 to principal, right? Passing 1000 to principal and period and rate, they are keyword argument. That's why the position is doesn't matter. Remember that in the case you use a mix, in the case you use a mix the keyword and positional argument here, the positional argument is must be you have to put it first. What is it? Okay, this one here. The function can be assigned to variable, pass as the argument, and return as the value of the function. You can think about the function as a variable, right? So in that case, the variable you can passing it to another variable. You can passing it to the argument into the another function. It doesn't matter. You can totally flexible with this one here. So think about this one here, right? You have the sum of the you have the sum of the built-in function here. You have the absolute here, and then print it out here. Now you can think about this one here. You can think about this one. The function here, right? That is the name of the function, and you can define it as a variable here. You can assign it as a variable name, right? So we say you assign the function ABF to the variable f, and now every time you call f here, you call it f. Actually, it's reference to the function absolute here. So basically, you see the function again. You can use as a variable, right? So it's totally flexible with this one here. Okay, and so you can put the function into the list here. You can put the function into the list. You have the ABS, you have the square here, and now you can print it out. You can print it out the function here. Go on the ABS and the passing argument is number -10 here. Okay, now you have the mapping, and now we have the filter, and have reducing and lambda. So that I think is very interesting. That is beyond the normal function normally in everyday here. The mapping applied to the function to each value in the sequence and return the sequence of the result. Example, you have the list of name words that contain strings that represent the integer, and you want to replace each string with the corresponding integer value here. Think about we have the word here. You have the word, right? In that you have the list of the words that contain string. Now see, they are string format, right? When we put it in the double quote, they are string format here. Now you want to print it out. You want to print it out in the integer format. You want to print it out in integer format. So basically for this one, right? Basically for this one, you can work it very simple. That you run the loop for every element of the list, right? And you convert it from string format to the integer. Right? So think about this one here. You can use the loop, right? You think about this one here. Let me open this. Okay. Now I do not want to do this one first. What is the second one? Okay. Okay, now let's do the first one. Find the first one. Yeah. Okay, so for this one, right? You have the list of the word, they are in string format, and you want to print it out in the number format. So basically think about the normal way you can do it here. The normal way you can do it is that you can use the loop, right? You can use the loop here for range, length, and width. Right? Okay. Now is that print, right? Print. Print what? What do you think?
INT.
Print. Print what?
Print.
Well, technically, I guess you could say I and they'll print each one of those. However, the thing you're printing out will still be a string.
String?
Print int parentheses I.
No, you have to accept into every single element of the list, right? Make sense? And for each element of the list, you have to
Oh,
convert it.
wait, hold on. My bad. It should be words. and-
Yeah, right. You
and
have to
words, and then
accept.
you do the.
You have to accept it, every single element of the list. That is the list name, and element is I here. It's running from the 0 to the end here, right? Now, anything else? What do you think? You have to convert this one to integer, right?
Okay.
Yeah.
Yeah.
You have to convert this one to integer.
So take it, yeah.
And of course, you have to put, if you want to put it separately, you have to put and equal to.
There's still an error because at the very bottom,
Yeah, you
You
did,
got the
you're doubled it, not triple.
Oh, yeah, right. What's this one? How to correct this one? Yeah. So basically,
-1.
no, I mean that you still have the comma here for the last one. So what
because
is
of
it?
the end, end equals comma, it's still going to output that.
Yeah,
You either have to have a conditional. I don't even know if strings have like a backspace function, like a slash p or something like that.
or you can use as a space here, it's okay, space here is okay. Yeah, but I want the comma here. Yeah, space is work. So how about this one? I want to do this one here. I have, and now I bring one more. Right? What length? See, what is it?
Index range.
Okay. You have let us put -1. Why?
You gotta get rid of the -1 in the for range. The
Ah,
third's
yeah,
fine,
yeah,
the
yeah,
for
yeah.
range one.
So we have to break it down. Take it down. Why is this? Why is thing out, French?
Words not length. Oh, isn't length? Wait,
-1.
that -1 is outside the index, isn't it?
Ah, here, this. -1 here.
Yeah, because then and then you need the finished
Yes.
on
Right?
the other side of the parentheses.
What?
So it should be len words -1, and then it's the end of the square bracket. You have a parentheses there instead.
So I have what? I have length of what? -1.
It's the square bracket should be on, yeah, and then there should be a.
Yeah, one more.
And then hopefully it should work.
There we go.
Yeah. Yeah, so we had to manually do it. We had to manually do it.
I'm sure there's a more graceful way of doing it. Oh, whatever.
Okay, so here's that's the basic concept, right? For each element is the array. Each element is the array, except if element is the array, right? Convert it to the integer and print it out. That's the process, right? That's the process here. But you can improve it when you work the mapping here. So when you work the map, you can see in the program here how it works with the map here. Let me delete all of this one. Let me delete all of the one here. Now I come back to this program. Okay. So when you work with the map, bye equal when you work with the list here. Right? So when you work with the I have to see. Okay. So when you work with the map, right, you have the user list here and the map. In that, what is that? It take it out every element in the word, convert it into the integer function here. I convert it into integer function and is that mapping each element together. Each mapping each element together. So basically for this one here, you accept the syntax is that the syntax of this one here. You take it out the name of the list, take it out the name of it, and take it out the function. What is the function you want to do with each element of the list here? And also after that, you mapping every element together and you build it into the list here. You sort it for everything in the list. So remember that the function here, you can do any kind of function to the if you want to do the map. That this one is a function, it is a built-in function. But actually you can define your own function, right? Think about if you want to double the number here, or if you want to do the square root, or if you want to do the square of the number, it totally is up to you. And in that case, you have to define the function. You have to define the function and you call the function here in the map here. Now think about this one. This is very straightforward when you work with the built-in function already, right? Built-in function here. So basically process here, process of this one here. They take it out every element of the word. So see, take it out 231. Convert it into function int. That's why you have the number 331 here. And you move to the second one. Take the 20, convert it to the 20 here. Take this one, convert it to 45 here. And this the last one, convert it to 99. And at the end, okay, we take everything in the list here. Now see, I run it again. I run it again for this one. Okay, so see the process here. And the process here, take it out the number, do something with the function. Mapping each of the element with the function here. Mapping with the integer, mapping with the integer, mapping with the integer, mapping with the integer, and put it inside the list. Make sense? Okay, so in that case, you are the one who use the built-in function in, but actually you can do with any function. You can do with any function here. Now, in the second example here, in the second example when I work with this one, I do not use with a built-in function anymore. But this time I want to work with my own function here. I work with my own function. I define the function, and the name of the function is double here. And you have the one parameter here, right? So what's the double? For each of the number, I just time it to number 2 here. I time it to number 2 here. And that is my list here. That's my list. 1, 2, 3, 4, 5, and so on here. Right? So what happened here? I print out the original list. You have 1, 2, 3, 4, 5. But now for the second one, I have the new list. What's the new list? New list, I access it to the old list. And for each element, I call the function double. I call the function double here. So what happened here in my program? What do you think about my program?
Takes every number in org and times it by 2, then adds it to the new list.
Yeah. So what do you think? What is the output of this program? If you look on this one, what's the output of this program? What are the outputs?
It's going to first print out org, and then it's going to print out 2, 4, 6, 8, 10.
Yeah, right. So basically that's the old one here, original here, right? Now see the process here. Take it out every element. Call the function double here. double it, and matching each element to the together, and I put it into the list here. I see that we run it here. I have the old list here, and I have the new list here. Right? Makes sense? So basically, again, when you use the map here, when you use the map, the function here, you can use with any function. It can be the built-in function, or you can define your own function here. Right? Makes sense? Okay, you can use the built-in function for this one here. So I think it's very helpful is that you want to processing the list. You have many elements in the list here. Basically, for this one also, we can work with the loop, right? You can do it one by one. But when you use the map here, it's way better. Way better. Now, another one is the filtering. Filtering is a function called a predicate. It applies to each value in the list. If the predicate return true, value is added to the new list. If not, just drop it here. Right? So the Python includes a filter function that used in the example here. Now think about here. I want to find out the list of all the odd number, iterating from the number 0 to number 9 here. All right. So what happened here? The first thing I have to define my function. It's an odd function here, and in that again, I have one parameter here. All right. So again, I know that if the number that is a remainder, right? When you divide by 2 and you have remainder number 1, you return 2. That is an odd number. If not, you have the 4 here. So here, you have the filter here. The filter it is a function. It already defined in the Python. Again, it works quite the same. With the map. But this one here, whenever true, it adds it to the new list. But not true, it just drop the number. I have to think about this one here. In the range from the 0 to 10, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so how it works here? It works with filter. It take it out every element in the list, and check the condition here of the function. If true, add it to the new list. If not, drop it. So you see at the end of the process here. At the end of the process. Yeah, you have 1, 3, 5, 7, and 9. So we think the range is not include 0, right? Yeah, 0 is not odd number.
Because it has to equal 1 and 0 is less than 1.
So see, for this one, you can filter. Again, that is definition. That is a function here, right? That is a function. And of course, you can flexible with that function. You can do it whatever function you want. Make sense? Okay, it can do with whatever function you need. With this one here. Of course, this one also you can work with the loop, right? You run it every element and you check it if not or not, and if everything is correct, you add it to the list. Right? So think about this one here. You can do it on the same way, but I think it's a filter way better. Think about. So now, in the traditional way, how we work with this one. If you do not want to, if you do not work with the filter here, how we do it?
Yes, 4 in range.
You have to define the new list, right?
Yeah.
And the new list at the beginning is empty here. Right? So every time you run the loop, it is an odd number. You add it to the list, right? So think about new list. Okay, I think it should be my new list. For at the beginning empty here, right? So for in range
Then
10 here and then 10, right? Now you have to check it, right? If odd and if odd add it, right?
Yeah, append,
So new list here,
At pre-end,
new list append. You have
Yeah,
to,
append.
yeah, you have to append it. Append,
then I,
huh? And at the end is a print down.
Yeah.
Yeah, you do the same, but you see, the process is that you have to do with every single element. When you work the filter, way better, right? Way better. What's it?
oh, it's,
Okay.
the length is just 10, but you
Yeah.
can probably just do range 10.
Yeah, or 10. No, not like that. In range only. Right?
Yeah.
Yeah.
That should be fine.
Yeah,
That
range
would
only.
make a list.
Yeah, range only.
there we go.
How about this one? What do you think? How about this one? If you do not work with the map, how we work? I work it here.
Forcing all of those to.
List,
Okay, now you have to do the same process. You have to minus 0, right?
Mhm.
And so you have to call in range, length, and what was
words,
what happened here?
You just say my list, dot append, and then you do int in parentheses I. And that's it.
Yes. Now, in parentheses, what?
I,
Not I.
Oh, wait.
Okay, it's worse than, the
Yeah,
index I.
yeah,
I keep thinking that we're going to just do
yeah.
words. Okay.
Okay, that. The map at least is way better.
it shrinks it down so much.
Yeah. Yes.
You did not have a print
Not
function.
really, yeah. Really.
Real quick, just print my list. There we go.
Yes, so I think it's very helpful if you work with processing a long list, right? You work with the map and the filter here. Now, as the one reducing, what do you do with reducing here? When reducing, we take a list of value and repeatedly apply a function to accumulate a single data value. So you try one to produce sum and one to reduce the program.
So instead of having a list as an output, it compiles it to one single output.
Yeah, right. Okay. Yeah.
So instead of showing 1 plus 1, 1 plus 2, 1 plus 3, it just shows you the final answer.
Yeah, it's a final answer here.
So it's just a way of saying, hey, only show final.
Okay, so basically, for this one, you have to import the reuse here from the module funds tool for this one.
So we should get 10 and 4.
Okay, and you have to define the two. You have to define the two function here. You have to define it. Right? For this one, you have to return x plus y. This one return x times y. Now you have the list. Right? So for this one here, so basically apply it only for the original function. We apply it to the two parameters, right? But you see, it can apply it to the list of many elements. It doesn't matter. So instead of that, you see, instead of using the loop running from the first element to the last element, right? In the case of the sum, you have to initialize the accumulator. Right? You see, in the case of the multiplier, so we have to initialize number 1 and run it. Right? Now it's way better. I think even that you have many many element here, it doesn't matter. Many element here in the loop, it doesn't matter. Yeah, I think it should work very well for this one. Take out the list, apply the function here, but you understand that instead of the 2 elements, you have to do every element in the list. You have to do with every element of the list. Okay, so I think, yeah, I think it's very interesting when you work with this function here. From now, if you are processing with the list of many elements, you can use about math, right? You can use about math, you can use about reduce, and you can use about filter here, right? A lot of applications work with this one. Now, I think that's the last one. Using the lambda to create the anonymous function here. Lambda is an anonymous function. When the lambda is applied to its argument, its expression is evaluated and its value is returned. The syntax of the lambda is very tight and restrictive here. You have the lambda, you have argument number 1, argument and so on, and expression here. Now see how it works, the lambda here. Now we can now specify addition or multiplication of the fly. As the next section here, you have data, you have reduce. Oh, okay, I got it. So basically here in the reduce, in this example, right? Before you apply reduce, you have to define the function here, and you have to define the function. And in that one, you have to define what is the add function, what is the multiply function here. But the lambda, you do not have to define it first. You do not have to define it first, but you can call it later here, and you can define it later. That's why they call it the anonymous here. You do not have to define it at the beginning. I see. When you work with this one here, you have return and reduce lambda. Now that's the time you define with the lambda. What is it? You have x and y is a parameter, and which return you with the value x and y. So basically, this one works exactly the same with the example when you work with the function adding here. But when you work the lambda, you do not have to define. Do not have to declare the function in advance. You can use it later when you work with the reduce here. So basically, again, the same. I apply that. You understand that when you call the lambda here, it understands that it accepts into the list, and x plus y, that means summing up every element of the list together. That's all. Right? Okay, makes sense? Okay, that's all. And for this one here, you have the lower and upper for this one.
I believe I use lambda in the homework for sorting the grocery list.
Yeah, you can do that. Yeah, so in that case, you have to define how it works, right?
Yeah, I use lambda to define that it should sort by the value and not by the name. If I'm remembering correctly. I have it here somewhere.
I think, yeah, I can do it later for this one. Now, 10:30. Yeah. And that's almost all for this chapter here. And in this chapter, you can go with the lecture on Thursday, but actually you move it. Now for the homework, I still not understand what is the requirement for this one. Only thing I have to ask someone.
I really don't.
Yeah, I do not understand what the requirement. What is
You
the
know
point?
it's bad when you, the guy teaching us Python, does not understand what the homework is asking of us.
Okay, sorry for that.
That's a,
I have to answer one who developed this course. What is the purpose of this requirement for this one? I do not understand.
Like, I get what they're trying to ask you, which is to like use the whatever code and then see what's wrong with it, but I don't know how they're supposed to ask. I don't know
Yeah,
how they're
that-
checking how you know how to debug the
Yeah,
problem.
that is my problem. I do not understand what is supposed to do with this one here. That's why. I do not know.
I
And
just cheated,
yeah,
because it's like, I don't know how they're supposed to expect us to do any of that.
yeah.
What did you do?
Let me
I just
ask
cheat.
let me answer the guy who developed this one.
If you
I'll
want,
come back to you later on Thursday. And this one, I think this one very simple. This one very simple here.
I believe I finished that one. That
Is
one's more possible.
This one very simple, yeah, this one.
I think I did it the dumb way. but- Oh, I did it the dumb way. But yeah, it's possible.
Is that one to bring it down, but you do not use the range, right?
Mhm.
Right, that's all. Yes, that's the way I work it, but anyway, you can work it by the wall. It's up to you. Okay, anyway, I see you on Thursday and review about this module and I work with you on the homework.
Yep.
Okay, and see you guys on Thursday. You have any question for guy online?
wow, look at the two slackers, Wesley and Cole.
Nope.
Okay, thank you. Bye, you guys. See you on Thursday.